All right, so today we're going to look at some more complicated U substitutions, okay? In this case here, we're trying to find the antiderivative of x squared minus x times 2x cubed minus 3x squared plus 1 to the third power dx. Now, if we didn't have U substitution, guess what we would have to do?
FOIL it out.
We'd have to multiply this whole thing out.
Let's do it.
And then we could use the power rule. And would we be correct?
Yes.
Yeah.
A lot
But-
of mistakes.
But there's a lot easier way. Now, one thing we have to do, remember, for our U substitution is identify what the inner function is. What is the U in this case?
2x cubed minus 3x squared plus 1.
Okay, the thing that's being cubed, it's inside the cube, that's our inner function. So that 2x cubed minus 3x squared plus 1 is going to be the U. And then remember our process. You identify U, we take the derivative, okay? So this is du dx, which is a 6x squared minus 6x. Okay? Now I'm going to multiply both sides by the dx, and that'll tell me that the du is 6x squared minus 6x dx. Okay?
Why does dx matter?
It matters because that's our differential. That without that we don't really have an integral. Okay? Because remember, integrals, we're finding areas of rectangles. And that dx is the base and the function inside is the height. So you got to have base times height to find the area of the rectangle. Okay? Now, as I look for my du, I see the dx, okay? But instead of a 6x squared minus 6x, I only have an x squared minus x. So what can I do here?
Multiply by 6 on the inside and 1/6 on the outside.
Okay, yeah, that's what we're going to do. We're going to multiply by the 6 on the inside. Let me get a darker green there so we can see it. We're going to multiply by the 6 on the inside and a 1/6 on the outside. Okay, because again, we're just going to multiply by 1 so we don't mess up the problem. Now, I can do that substitution to where this combined with all of this is du. And I have a 1/6 times the integral of u to the third du. Okay? So remember, u was all of this. So I'm replacing that with a u. Okay? Now, what's the integral of something cubed?
1/4.
Yeah, 1/4 something to the fourth, okay? So this is, I still have this 1/6, and then I have that u to the fourth, 1/4 times that. So u to the fourth over 4. Okay? Now, we're not allowed to leave the u's in our answer at the end, so now I need to substitute back in, and I have a 24 on the bottom, and I have the 2x cubed minus 3x squared plus 1, all raised to the fourth power, and now I'll throw on the plus c at the end.
Wait, where'd you get the 1 for? Or u for? Oh, okay.
So one rule about this, though, if I'm missing, notice here we were just missing a constant 6.
Right.
If I'm missing x's, then we can't do this. You can't multiply by an x on the inside and a 1 over x on the outside. That doesn't work. Okay? There are other strategies that we'll look, after our unit's done, we're going to come back and do some more advanced U substitution. We'll look at how to deal with those then. Okay? All right? let's just try, with the time we've got left here, let's just try one or two more here. Pick one. What do you want to do?
4C. No, 4D.
There's number 2 or number 3 on
It's
this
on the
page.
page.
All right.
I didn't
4D?
get it.
Okay, 4D. 4D. Okay, this is an interesting one. All right, so 4D. The question on this one, what do we make the U?
You bring up the bottom
X cubed minus
and you make that the U.
going down.
Well, let's make the bottom the U. Okay? For one thing, remember we're going to have to find du, which is the derivative. If I have a cube on the bottom and I have a square on the top, the derivative of a cube is a square, right? So chances are the cube part is going to be where the u is. Okay? So that's just a little bit of logic you can use there. So if u is x cubed minus x, what is the du going to equal?
3x squared minus
3x squared minus 1 dx. Okay? Now, this is kind of interesting here because notice what I've got. I don't have a 3x squared minus 1. What do I have?
6x squared minus 2.
divide by 2.
Okay, so here, this one is a little bit different because we're not going to multiply by something and divide by something. We actually just need to factor. This is the integral of 2 times 3x squared minus 1 over the x cubed minus x. And you'll notice here that 2 I can actually just pull out of the integral. And I'm going to rewrite this. You wouldn't necessarily, once you get the hang of this, rewrite all of this, but I want to show you everything here. So I now have 1 over x cubed minus x times, and I'm going to put this over here, a 3x squared minus 1 dx. And I do that so that you guys can see here, notice the du was the 3x squared minus 1 dx. And now I have that right here. Okay? So you have to manipulate it a little bit in order to get the du properly in there.
Is there a way that you could do it without?
You
Alright,
can do it.
never mind. No question.
A way that you could do it without the u substitution?
No. It was just more of like factoring out the two, but no, you can't.
Okay. Alright, so now we have 2 times the integral. Let me get back on the pen. 2 times the integral of 1 over u du. Okay? Yeah, now we know that the integral of 1 over u is ln of absolute value of u.
Those 2 ln.
Okay? So we have 2 ln of the absolute value of u. And we can go ahead and plug the u back in now, or we need to go ahead and plug the u back in. So 2 ln of the absolute value of x cubed minus x plus c. And there's actually one more step we could take. What could we do with that 2?
Oh, we can put it as a square.
Yeah, and you know what's cool about that? If we bring the 2 in as an exponent, because remember if you have a log times something, you can bring that constant in as a square. The reason why that's cool is because I'm squaring it, I know this will always be positive, so I don't need that absolute value anymore. Okay?
Oh.
Because I'm squaring it, I know it'll be positive, so now I don't need to do the absolute value.
Are there a lot of problems that will have absolute value? Is it just like for this one?
It's really only this rule. This is the only rule when you have that 1 over u or the 1 over x. It's the ln of absolute value of x.
Okay.
And the reason for that is because 1 over x could be a positive number or a negative number.
So you just do absolute value.
Yeah, but the ln function can only take positive values, so we have to do absolute value.
But technically for IB, they just assume we know that, right?
Well, no, you should go ahead and
Yeah, do
use
it anyway.
use the absolute value. I said in the book, in the solutions that you might find, sometimes they don't put the absolute value in the answer, but we really should. Okay? Alright.